Let's take a quick look at throttling and rate limiting. Throttling is the practice of slowing down access to a site or a service. It's used not only in censorship, but also it's a common network management task for resource management, or, for example, it can be used to ensure that one user or application does not overwhelm the available network capacity. Hence, it's often used to allocate resources across users for a shared resource and to prevent the adverse effects of network buffering on latency. Because throttling is a common practice, and also because network congestion often occurs, it can be difficult for a user to distinguish intentional censorship from normal practice, network congestion, and other effects that might naturally slow down the performance of the network. A common way to implement throttling is a leaky bucket traffic shaper, developed several decades ago at Washington University. The concept is quite simple. Data may come into the bucket at variable rates, but conceptually you can think of this bucket as having a small hole in the bottom that trickles the data out at a fixed rate, which is typically less than the capacity of that network link. The regulator thus controls the rate of the traffic that's sent on the link. Each traffic flow is assigned its own leaky bucket, potentially with different rates, thereby allowing different flows to be sent at different rates. The bucket also has a size, and if that bucket ever fills up, that allows the regulator to also drop traffic. Because TCP reacts to packet loss by slowing down, dropping traffic is another way of slowing down a network connection. That practice is sometimes called policing. Another way to regulate traffic rates is through what's called a token bucket traffic shaper. In a token bucket traffic shaper, tokens arrive in a bucket and they leave the bucket at a particular rate. In a token bucket traffic shaper, tokens arrive at the bucket. As long as there are tokens in the bucket, the regulator will allow data to be sent from the buffer. The token bucket also has a size. Tokens arrive at an average rate, but they accumulate, thereby allowing the sender to send periodically for short periods of time at rates that may exceed the average rate at which tokens arrive in the bucket. But the regulator will never allow more data to be sent than corresponding to the amount of tokens in the bucket, thereby limiting the overall peak rate. Here are some comparisons. Here's a comparison between a token bucket and a leaky bucket traffic shaper. The token bucket permits burstiness but bounds it. A leaky bucket forces that bursty traffic to smooth out. There are a bunch of other small differences between a token bucket and a leaky bucket, but they're both relatively easy to implement. Throttling and rate limiting are an example of what Roberts calls friction, increasing the cost of accessing a site or service by slowing it down. It's very hard to detect reliably. There have been some attempts to document this practice in certain countries, though specific experiments to monitor throttling, particularly over time, have been limited. So we've looked at a number of ways to censor or manipulate protocols, interfering with communication by blocking or injecting packets into TCP/IP, by manipulating or redirecting the DNS, and by blocking or hijacking BGP. Throttling or rate limiting increases the friction for accessing sites and services. There are many open problems for detecting these different types of manipulation.